now move to the horizontal projectile motion, and that is clearly shown on your screen here in this diagram. But let me explain you what is actually happening. Like, let us say this is a building, high-rise building, and there is a ball or a projectile. So we are kicking that projectile and we are giving it a horizontal velocity. So it is only having the initial horizontal velocity, but there is no vertical velocity initially. So when it starts going in this way, obviously we know that it would be going somewhat like this. Kind of this, you can assume. Yeah. So this will be the horizontal velocity, and initial velocity, there is like, it is zero initial velocity on the vertical plane. The height of the building is given, and we do not know the range. We want to find the range, and we want to find the time of a flight. These are the two things that we want to see now. Okay. So again, we will be moving into SWOT equations, but let us see how we're doing it. Let us assume an instantaneous position of the body at this point. The time that has elapsed is kind of t, and so it will be having horizontal direction velocity, a vertical direction velocity, and there will be total velocity like this. So this will be, you can call it like vh, this will be vv, and this is the final velocity v. Okay. So the point number one that we have to note here is there are two motions which are overlapping here. What we do, we create one horizontal shadow, which is this, and we create another, sorry, vertical one, and this is the horizontal shadow. So these are the two shadows that we have created for the body. Now, this body here, I'm going to name it as A. So A shadow or A body is only and only having the vertical motion. It is only having the vertical motion and it is going downward. But this horizontal is having only and only horizontal motion, which is going in that direction. Now, as a matter of fact, we know that in the vertical axis there is an acceleration, which is acceleration due to gravity, which is downwards. But on horizontal axis there is no acceleration, there is no force. We are not considering drag force, we are not considering any force which is facilitating the motion, nothing. So it means that there is neither acceleration nor retardation on the horizontal plane. Okay, only and only vertical, which means that the horizontal velocity is never going to change. So point number one that you can note here is that I would be writing here anyways, like the horizontal velocity is always equal to u, whatever time has elapsed and whichever position or location you're talking about, the horizontal velocity is not going to change. So this is equal to u. Now, so first of all, we would be concentrating on the vertical motion. So only on the vertical motion, and from this vertical motion you can find the time t, because h is given, the height is given. So this is just acting as if you have dropped a body, isn't it? Like, it's similar to dropping the body. Why? Because on the vertical plane the initial velocity is zero for the vertical motion. So we want to find the time now, and we have only this. So the only SWOT equation possible for us will be v square minus u square is equal to 2as. So no, even the final velocity is not known to us. Yeah, s is equal to ut plus half at square will be the correct formula. Now u is taken to be 0 as per the vertical motion is concerned. There is no initial velocity, so ut is 0. And before we move here, even I am forgetting this thing again and again, isn't it? Sign convention is very important. We have to convey this thing. We have to write this sign convention whenever we are solving a numerical, whenever we are doing the theory, there will be a sign convention. Let us say the downward direction is positive, upper is negative. Why I have chosen downward direction as positive? Because everything is moving downwards. Gravity is downwards, velocity is downward, displacement is downwards. So it will be easy if we are choosing the downward direction as positive. Although there is no condition on it, you can choose any direction to be positive and any direction to be negative. Sign convention is completely based on your whims and fancies. Okay, so this is downwards, and as I have earlier told you that the position where the motion starts, that will be assumed as origin. So all the measurements will be made with respect to the initial position only. So clearly the displacement is somewhat like this, S vector, or we can just call it S. So displacement is downward. So downward displacement will be taken as positive and the magnitude is equal to capital H. So I am going to plug this value here as plus H. Now ut is 0, so half, gravity will be positive again because it is in the downward direction. Gravity, the magnitude is g. And obviously we are talking about the total time. There is no significance of small t because we are considering the total displacement. So this is the relationship between the total height and the total time. So time is coming out to be equal to root of 2h by g. Have we seen this formula earlier? Well, yes, we have seen this formula when we were doing the case of dropping of a body from a height h when u was equal to 0. We found the same time period. So now, here is a fun fact. What is that? If there are like two bodies here, let me create this kind of a building now. Let us say there is one body which I am dropping from this, and the u is equal to 0, and there is another body which I am giving only and only the horizontal direction to it. Both of them are having the same time of flight. It means that both of them will land on the ground at the same time. Although this is covering a very less distance and this is going to cover a lot more distance here, that depends upon the initial velocity that you are giving. If it is too much, it would be covering a lot distance. So this is the range. Even then, the time of flight in this case is equal to the time of flight in this case. Isn't it cool? You can even give it a try. Just have two bodies, and you keep them one body on the table, and you try to hit the body on the table, and you drop one another body and try to listen to the sound that is created. Okay, and you will be really surprised to find it that yes, it is taking the same time. Okay, so this is the concept that we have learned here. Okay, so time of flight we have found. Now what about the range now? So range is the horizontal direction, and we would be concentrating on the horizontal direction now. Yeah, you can just pause the video, you can go back if you want to see things. I'm just erasing it to my convenience. The point number 2 is now we are concentrating only and only on the horizontal direction motion. Now in horizontal direction, now we know that the acceleration is 0 and the horizontal velocity is always constant, which is equal to u. So this becomes a uniform motion. In the uniform motion, this is completely simple thing. Displacement is equal to velocity multiplied by time. So the velocity we know is u all the time. And so the range here can be taken as velocity multiplied by the time. So the velocity is u and time we know that it is root of 2h by g. This becomes the formula for the range. Now again, do not remember these formulas, like it's not very crucial, like you have to remember each and everything. If you remember, it's very good, but if you don't remember, you must know how to do these things. Okay, so this is the range that you have here. So we found the range, like let us say this point is b, this point is c, so you're talking about bc length. So we have found the range also, we found the time of flight also, and that's it. There is only one more thing that we have to find, and that is the final velocity. Let us say the final velocity is at this point. Let us concentrate at point C now. Okay, you can take your notes for this, and I am going to erase this. Sometimes I have seen like they are asking questions on the final velocity here. What is the final velocity with which the body is going to hit the ground? So this is the final velocity. I'm going to call it V. This is the horizontal velocity, which is always going to be u. And this is the vertical motion velocity, which is going to increase its value. So further it is away from the origin, more it is. So we have to find the velocity v. And then we can apply the Pythagorean theorem here, because this is definitely going to create a right angle triangle. The triangle will be somewhat like this. Okay, it's all about the drawings, no, like because I'm using this pad kind of thing and all that. So drawings are not always that perfect. So you have to imagine it from your point of view. So this is u and this is vv. This is the final velocity. So this is the third point that we are finding, the final velocity with which the body is going to hit the ground. So I'm going to apply the Pythagoras theorem here, u square plus vv square. Now, what about this v square? So this v can be taken as v is equal to u plus at. So I'm utilizing this space now. So don't be confused. So vv is equal to u will be taken as 0 in the vertical plane, isn't it? Okay. This is the equation that I would be applying on vertical motion. So u will be taken as 0. So this is vv, and that even in positive direction. Gravity is in the positive way. This is the time t. Obviously, we are referring to the total time, so I can just write it as capital T here. So v is gt. So this can be written as g capital T square. So v is equal to u square plus gt square square root. So this becomes the final velocity with which the body is going to hit the ground. So this is the formula for your final velocity, and that is the only last thing that you were supposed to note in this topic of horizontal projectile motion. That's it. So I think everything will be clear now. So if there is any other doubt and you want to say anything, you can either message that in the comment section, or you can even message me on the WhatsApp. No problem at all. Okay, dear students. So now in the next video, we are going for the oblique projectile motion. So be with it, and let's see you in the next video. All the best. Bye.